Hi, this is Janak Reddy Dubbaka, Physics Rapid Revision course for NEET and Mains. This is lecture number 4 from Semiconductors. In this lecture, we are going to discuss some numericals on PN junction diode. Here, while doing any problem related to PN junction diode, if in a circuit there are a number of diodes are there, first we have to decide. For example, in a branch, there is a diode. It is connected in between A and B. First of all, we have to decide whether it is in forward bias or reverse bias. Forward bias means P side is connected to high potential and N side is connected to low potential. This is in forward bias. When it is in forward bias, if it means it is a low resistance connection, if the diode is ideal, it acts like a short circuit. Means in between A and B, in place of diode, I have to connect one conducting wire A and B. For example, if diode is in forward bias and it is a germanium diode, therefore in this case, in place of diode, we have to connect one battery in between A and B. For germanium, its potential difference is 0.3 volts. For example, it is a silicon, 0.7 volts. In some cases, in forward bias or any reverse bias also, if it is having internal resistance, therefore if you want to write, see for example, A and B, this is a germanium diode. It is in forward bias. Therefore, in place of diode, I have to write down one battery and also some internal resistance. For germanium 0.3 volt, this is internal resistance. For silicon 0.7 R. If the diode is in reverse bias, now it is in open circuit. Therefore, in place of diode, then you have to remove the diode. There is a open gap. Now in that branch, no current passes through that one. This is act as a open circuit. These are the things we have to decide while doing the problems when there is any diode is connected in a circuit in any branch. See, here some problems. Which of the following circuit represents a forward bias diode? Forward bias means P side is high potential, N side is low potential. Here is -10, this is 0, low potential to high potential, it is not a forward bias. Next B, this is -10, here is -15, -10 is greater than -15, therefore it is in forward bias. Next C, this is 4 volt and this one is 2 volt, high potential, low potential, this one also forward bias. And here P side is -10 and this is -5, therefore this is low potential to high potential, reverse bias. And here P side is 2 volts, N side is 0, this is forward bias. Therefore B, C, E are in forward bias, therefore option C is correct. Second one, which of the following circuit is in reverse biased? See, reverse bias means low potential to high potential. This is 2 volts, this is 0 volts, high potential to low potential, this is not in forward bias. And here P is 0 potential and this one is -5, this is also not in forward bias, not in reverse bias, this is in forward bias. This is 0, -5, 0 is greater than -5, this is in forward bias. Here P side is +2 and N side is -2, this is also forward bias. And here P side is +2 and N side is +4, low potential to high potential, and this is in reverse bias. Therefore, only D is correct. Next one. What is the current through the battery in the circuit shown? Here first, which one is in forward bias and which one is reverse bias? Here this P side is connected to positive and this P side also connected to positive and this is negative, this is negative. Therefore, both are in forward bias. Both are in forward bias means low resistance connection. Then in place of diode, we have to draw one line itself. Therefore, this is 20 ohms. This one also 20 ohms. This is 5 volts. Now, these two are in parallel. Therefore, R equivalent is equal to 20 by 2. therefore 10 ohms, therefore current I is equal to V by R equivalent 5 by 10, that is 0.5 amperes. Next one. Here, refer to the circuit diagram given in the figure. Which of the following observations are correct? Here, first of all, diode is in forward or reverse. This positive terminal is connected to P, therefore it is in forward bias. When it is in forward bias, these two resistors are in parallel. Therefore, these two resistors are in parallel, 4 by 2, 2 ohms. And this 4 ohms and 2 ohms are in series. Therefore, R equivalent is equal to 4 plus 2, that is 6 ohms. Therefore, current I is equal to V by R equivalent. Therefore, V is given as 6 volts and R also 6. This is 1 ampere. Next one, here, this one is 4 amps. Instead of these 4 and 2, 4 and 4, I am writing 2 ohms. This is 4 ohms. This one is 2 ohms. Here I am taking potential V1. Here is potential V2. Therefore, V1 is equal to I into R. I is 1 ampere. Resistance 4. Therefore, 4 volts. And V2 is equal to I into R. 1 into 2. That is 2 volts. See, first option. Total resistive circuit is 6 ohms. A correct. Current in the ammeter is 1 ampere. B also correct. Potential across AB is 4 volts. AB means combination of these two, that is 2 volts. That is 2 volts. Therefore, C is wrong. The potential across CD means this one, 4 ohms. That is 4 ohms. Therefore, D is correct. Therefore, A, B, D are correct. Next one. In the circuit shown here, assuming the threshold voltage diode is negligible, then voltage VAB correctly represents. See, for example, for input AC, this terminal as plus and this terminal as minus. Here, this P side is connected to negative and N side is positive. Therefore, this is in reverse bias. In reverse bias, it is a high resistance connection. Therefore, there is no conduction of current. Here is a gap. Next one. For example, for next half cycle, this is minus and this one is plus. Therefore, here P is connected to plus. Now it is in forward bias. Therefore, it will conduct the current. But A is connected to minus, B is connected to plus. Therefore, VAB is equal to negative. Therefore, output signal negative half cycle negative. Here is negative. Therefore, option A is correct. Next one. In the given circuit, the voltage across load resistance RL is voltage across load resistance RL. Here, here is germanium is given. For germanium, potential drop is 0, barrier potential is 0.3 and this one is 0.7. Both are in forward bias. For this closed loop, we are applying KVL. For example, here is A, this is B, this is D. Therefore, KVL for the loop A, B, C, D, A. Therefore, we started at A and reaching to B. Therefore, negative to positive, therefore, potential increases. Therefore, here potential 15. And from here to here, we are moving. Potential A to B, current is moving from B to C, therefore, potential drops. Therefore, total potential minus 0.3, 0.7, that is minus 1. And here, current is I. Therefore, in the direction of current across the resistor, current and resistance is negative. Minus I into, this is 1.5 and this one is 2.5 kilo ohms means into 10 cube is equal to 0. 15 minus 1, that is 14. Minus comes this side. I into 2.5 into 1.5, this is 4. 4 into 10 cube. Therefore, I is equal to 14 by 4 into 10 cube. This becomes 2.5 into 10 to the power of 3. Therefore, this becomes 40, sorry, sorry, 14 by 4, this is 7 by 2, here is 7 by 2, 7 by 2 into 10 to the power of minus 3. This is the current. We have to find out voltage across load resistance. Here, voltage across load resistance, current into resistance RL. Current is 7 by 2 into 10 to the power of minus 3, and resistance is 2.5 into 10 cube. Therefore, these two cancel. 2.5, 7 into 2.5 by 2, approximately this becomes 8.75 volts. 8.75 volts. Next one. The value of net resistance of the network as shown in the given figure. See, first we have to decide which one is forward bias and reverse bias. See, this P side is connected to minus 8, N side is connected to minus 6, therefore this is in reverse bias. And here this P side is connected to minus 6, minus 6 greater than minus 8, this is in forward bias. Therefore, reverse bias is a short circuit, then this can redraw like this. It is in forward bias, therefore short circuit. And here 5 ohms, and this one is open circuit. Here it is 15 volts, and this one is 10 volts, and this is 5 volts. For example, these are between point A and B. Therefore, here there is no current, therefore it is inactive, and these two are in parallel. Therefore, RAB is equal to parallel 15 into 10 by 15 plus 10, 25. That is 5 5s, 5 2s, 5 1, 5 3. This becomes 6 ohms. Next one. Which of the diode circuits shown the correct biasing used for measuring the dynamic resistance of PN junction diode? Dynamic resistance of PN junction diode means it is in forward bias. Which one is in forward bias? See, this P side is connected to negative, this is 0, therefore this is in reverse bias. Here this P side is connected to plus 5 and this is 0, plus 5 is greater than 0, this is in forward bias, therefore option B is correct. Next one. A potential divider circuit is connected with a DC source of 20 volts. A light emitting diode of glow in voltage 1.8 volts, and the GNR diode of breakdown voltage is 3.2 volts. The length of PR of the resistive wire is 20 centimeter. The minimum length of PQ to just to glow the LED is. Here, the voltage between P and Q, that is equal to, this is 1.8 plus 3.2. Therefore, VPQ is equal to, this becomes 5 volts. This is 5 volts. Here, total potential between P and R is 20 volts. Therefore, VPQ is equal to total potential by total length, that is length of PQ into length of PR. I am taking 20 volts is in between P and R. Therefore, in between P and R, total potential is 20. Therefore, potential per unit length, that is 20 by length of PR into length of PQ. This VPQ is given as 5, that is 20. Length of PR is given as 20 centimeter, 20 into LPQ, 20 20 cancel. Therefore, length of PQ is equal to 5 centimeter. Next one. Light emitting diode is fabricated using gallium arsenide semiconducting material whose band gap is 1.42 volts. The wavelength of the light emitted from LEDs is, answers is in nanometers. Therefore, band gap energy is equal to 1240 lambda in nanometers. This is in electron volts. Therefore, lambda is equal to 1240 by E electron volts. Therefore, lambda is equal to 1240. Band gap energy is given as 1.42 electron volts. This becomes 875 nanometer. Option A is correct. Next, IV characteristics of an electronic device are shown in the figure. The device is, here in reverse bias there is a breakdown region. This is for a GNR diode. Therefore, GNR diode which can be used as a voltage regulator. C correct. Next, here assertion reason. A photodiode are preferably operated in reverse bias condition for light intensity measurement. Therefore, photodiodes are used in reverse bias condition. Assertion correct. The current in forward bias is more than current in reverse bias for PN junction. This is also correct, but it is not a correct explanation for assertion. Therefore, answer both A and R true and R is not correct explanation. Next one. Choose the correct statement about GNR diode. It works as a voltage regulator in reverse bias and behaves like a simple PN junction diode is in forward bias. First one is correct. See, GNR diode always connected in reverse bias. If it is connected in forward bias, it acts as a ordinary diode. Therefore, next one. Here assertion reason. Diffusion current in PN junction is greater than drift current in magnitude if the junction is forward bias. So, diffusion current is due to majority charge carriers and drift current is due to minority charge carriers. Generally, majority charge carriers is more than minority charge carriers. Therefore, diffusion current is more than drift current in forward bias. But whereas in equilibrium condition, unbiased state, both are same, but equivalent magnitude, opposite resultant current 0. Therefore, assertion is correct. Diffusion current in PN junction is from N side to P side if the junction is in forward bias. See, here diffusion current always from P side to N side, not N side to P side. So, here diffusion current in PN junction is N side to P side. This is wrong. Diffusion current is from P side to N side. Drift current is from N side to P side. Therefore, A is correct, or A is assertion is correct, R is not correct. Next one. A photodiode is used to detect optical signals. These diodes are preferably operated in reverse bias mode because fractional change in minority carriers produces a higher reverse bias current. This is the main reason. Fractional change in minority carriers produces a higher reverse bias current. Next one. Here, IV characteristics of PN junction diode in forward bias are shown in the figure. The ratio of dynamic resistance corresponding to forward bias voltage 2V and 4V. See, for PN junction diode, dynamic resistance R is equal to delta V by delta I. Generally, static resistance R is equal to V by I. But in PN junction diode, dynamic resistance is delta V by delta I. For example, for 2 volts, resistance R is equal to delta V by delta I. See, for this 2 volts, we have to take 2.1 and 2. Therefore, here the delta V means 2.1 minus 2 and corresponding currents are 10 and 5. This is milliamperes. Therefore, 10 minus 5 into 10 to the power of minus 3. Therefore, R is equal to 2 by 5 into 10 to the power of minus 3. This becomes 2.1 minus 0, this is 0.1, sorry, 0.1. Therefore, this becomes 1 by 5 into 10 cube. 1 by 5 is 0.2 into 10 cube. This becomes 0. Therefore, R is equal to 0.1 by 5 into 10 to the power of minus 3. When this point is removed, this becomes 1 by 5 into 10 to the power of minus 2. Therefore, R is equal to 0.2 into 10 to the 10 square. Therefore, this is 20 ohms. Like that, for 4 volts, we have to consider this limiter. Therefore, R is equal to 4.2 minus 4. 4.2, this is 250 minus 200 into 10 to the power of minus 3. Therefore, R is equal to, this is 0.2 by 250 minus 200, 50 into 10 to the power of minus 3. Therefore, 2 by 500 into 10 to the power of minus 3. This becomes 2 by 5 into 10 to the power of minus 1. Therefore, R is equal to 20 by 5. This is 4 ohms. Next one. As per the given circuit, the value of current through the battery will be. See, first, which one is in forward bias and reverse bias? See, this positive is connected to positive terminal, therefore it is in forward bias. This positive is connected to negative, this is in reverse bias, and this one is in forward bias. Therefore, here it is in reverse bias, no current is passing through here. For example, a current I is passing here, this can be divided, this is I2 and this is I1. The same I2 is passing through this one, therefore these two are in parallel series, therefore 16 ohms. Here also these two are in series, this is 16 ohms. This 16 and 16 is parallel, therefore R equivalent is equal to 16 by 2 plus extra 2 ohms, this is in series, therefore R equivalent is equal to 8 plus 2, that is 10 ohms. Then current I is equal to V by R equivalent, V is given as 10, therefore this becomes V is 10, R equivalent is 10, that is 1 ampere. Next one. The cutoff voltage of diodes in forward bias 0.6 volts. The current through resistance of 40 ohms is. Here this P is connected to positive terminal, therefore this is in forward bias and this one is reverse bias. Therefore, in reverse bias, it acts as a open circuit. Here, this is 60 ohms. Here it is in forward bias, but forward bias is 0.6 volt potential is given. Therefore, this is 0.6 volts and this is open circuit and it is connected to 1 volt and this is 40 ohms. Therefore, current I is equal to, these two are opposing each other, therefore 1 minus 0.6 by total resistance is 60 plus 40, 100, that is equal to 0.4 by 100, that is equal to 4 by 1000. Therefore, I is equal to 4 into 10 to the power of minus 3 amperes. Therefore, I is equal to 4 milliamperes. Here, this is forward resistance is 0.6. Therefore, this 0.6, this battery, they are sending the current in opposite direction. Therefore, resultant EMF is E1 minus E2. Therefore, E1 minus E2, this is 1, here is 0.6, 1 minus 0.6. Otherwise, you can apply the KVL also, we can get the same answer.